Hello children. Today we will continue our topic on relations with the type of relations. So we have relations as reflexive relation, symmetric, antisymmetric and asymmetric relations, transitive relations, equivalence relations and identity relations. So we will start with the reflexive relations. So one thing which I would like to tell you that all these types of relations are defined on a set of A. Basically they are defined on a set A, right? So we have relations on a set A, right? Now, uh, the reflexive relation, basically we will come to the definition part. A relation R, we will see the definition. Relation R on a set A is said to be reflexive if every element of A is related to itself, right? If every element of A is related to itself. So thus R is reflexive if XX belongs to R for all X belongs to A. So let us take a short example. Let I have got A as a set 1, 2, 3, right? It has got three elements in it, 1, 2, 3. So I have drawn a matrix of the universal set A cross A. A cross A is the universal set. So this is the matrix representation. In order to make the understanding easy, this is the matrix and representation which I have drawn. So this is the first element of A cross A, 1 cross 1, 1 1 and 1 2 1 3, then 2 1 2 2 2 3, then 3 1 3 2 and 3 3, right? Now these these are called the diagonal elements. These are called the diagonal elements because they are lying on the diagonal, right? So we have got 1 1 2 2 and 3 3 on the diagonal elements. Now the relation is reflexive if R has all these three elements called 1 1, 2 2 and 3 3. If all the three elements, because 1 belongs to A, 2 belongs to A, 3 belongs to A, that means 1 1 should also belong to the reflexive relation, 2 2 should belongs to the reflexive relation and 3 3 should also belongs to the reflexive relation, right? And the other elements may or may not present in this reflexive relation. The other non-diagonal elements, let us say 2 1 3 1 3 2, 1 2 1 3 and 2 3 are the non-diagonal elements, right? These are the diagonal elements and these are the non-diagonal elements. So if we talk about the non-diagonal elements in reflexive relation, yes, they can be present or they cannot be present in the reflexive relation, but we need to have 1 1 2 2 and 3 3 in the reflexive relation. So basically for all x belongs to A, my xx should belongs to the reflexive relation, right? And we should be aware that a relation is always a subset of the Cartesian product, right? So the first condition relation should have is to that it should be a subset of A cross A, right? And then the condition of the reflexive relation is that for all x belongs to A, xx should belongs to R. Now we will see some examples to make the understanding more clear. See, let A is 1, 2, 3 and R is a relation on set A. On a set A means A is related to itself, right? A is related to itself. So now whether we have to find out whether this relation is reflexive or not. All these are relations, and all these are relations means these all are a subset of the Cartesian product A cross A, right? Now whether this R is a reflexive relation or not, we have to find this, right? So R is 1 1 and 1 3, right? So because 2 belongs to A but 2 2 does not belongs to my relation R, therefore this relation is not a reflexive relation. So we need just an example to prove that it is not reflexive. If 2 is not present, my question finishes, with the answer that it is not a reflexive. We need not to move ahead. Yes, though we can also write that 2 does not belongs to A as well as 3 does not belongs to A. We do not have 3 comma 3 which belongs to this set, so we can also say that it does not belongs, it is not a reflexive relation, right? So one example is enough to prove that this relation is not reflexive. Now we will come to the second question, in which R is given as, the relation is given as this, and then we have to find out whether this is a reflexive or not. So we first of all 1, 2 and 3 belongs to A. That means 1, 1 should belongs to R. Yes, it is there. 2, 2 should belongs to R, and we will search for 3, 3. Yes, 3, 3 also belongs to R. So we don't care about the other elements. Yes, they should be a part of A cross A. They should be, the whole set should be a subset of A cross A. So yes, 1, 3 and 2, 3 basically are the non-diagonal elements of A cross A. So but because these three are present, we will say that the relation is reflexive. Now the third question, whether R is equal to A cross A, this is the universal set. This is the universal set. So basically universal set is a reflexive relation, because in A cross A, we have A cross A is the universal set, and it contains all the elements, the diagonal elements as well as the non-diagonal elements. So we will say that it is a reflexive relation. So if R is the question, example 4, if R is a null set or R is phi, so whether this relation is reflexive or not, no, this relation cannot be reflexive because it does not contain any of the diagonal elements. A is 1, 2 and 3. It does not contain any of 1, 1, 2, 2 and 3, 3. So it is not a reflexive relation, right? Now, so it is this universal is a reflexive relation. R is not a reflexive relation. Now we will come to this fifth example. This relation is given, so because A is 1, 2, 3, so 1, 1, 2, 2 and 3, 3 should be present in the reflexive relation. So 2, 2 is there. We will search for 1, 1 and 3, 3. 3, 3 is there, but 1 and 1 is not here. Though other non-diagonal elements are present, we will not care about those elements, but because 1, 1 is not present, so we will write, since 1 belongs to A, but 1, 1 does not belongs to R, therefore it is not a reflexive relation, not reflexive, right? So like this. So it is not a reflexive relation, right? Now we will come to the sixth part. It has got 1, 1, 2, 2 and 3, 3. Straight away we can write down that yes, it is reflexive because 1 belongs to A, 1, 1 is there, 2 belongs to A, 2, 2 belongs to R, and 3 belongs to A, 3, 3 also belongs to R. All the diagonal elements are present in A. We will not care about the non-diagonal elements which are present or not. This relation is surely a reflexive relation, right? So in this way we will find out, if a relation is given, we can find out whether it is reflexive relation or not a reflexive relation. So children, you just take out another examples, you take another set and find out whether a given relation is reflexive or not. We will continue our topic on types of relation in the next video.